Welcome to the next video. In this video, I want to go further in depth with type annotations. I'm here once again on the official documentation of the typing module from the standard library in Python. And I want to show you some abstract base types that are defined here in the typing module. So if I scroll down a bit, we can see, let me see. For example, here an example about using the iterable type. And whenever you have a parameter that should be iterable, which could be a list or a tuple or a set or a dictionary, for example, you could type annotate the parameter with this abstract base class, which is called iterable. As a note, every abstract base class here defined in the typing module or exported from the typing module starts with an uppercase letter. So for example, in the typing module, there is an abstract base class of a list, and this starts with a capitalized L, as I said. Okay, so if I scroll down a bit, we can see, okay, here starting at the part module contents, we see all the abstract types that are defined in the typing module. For example, we have the type any. This is an unconstrained type. So if you type annotate a parameter with any, you can pass in any type. So this type annotation shouldn't be used that much, because then you can just leave the type annotations if you annotate them with any, because you can pass in anything. So that should be used only rarely. Okay, then at next, as I said before, if a function doesn't return anything, you should use the return type as none. That is the case for functions that do not raise. If you have a function that just checks for a raise statement, so an exception could be raised, then you could use the no return type from the typing module, for example. As we can see, we have the function stop, and it always will raise. So there won't be a return none. This is a corner case. There won't be a return none. There won't be any return, because we will raise an exception and go up the trace stack in our Python code. So at next, there is a tuple. Once again, as I said, with a capitalized T here. And here you can define what type this tuple has. And you can define how many values the tuple should have. So if you have a parameter that should always have 2 values in a tuple, then you can define here we have a tuple with exactly 2 values. So if the 2 values have to be of type int, for example, you can type tuple of int, int, for example. As I showed in the last video, there is this union type, which just says union of x, y, means the type is either x or y. So any of the types listed in the union here are okay. So we have, for example, here union of int or string. So the passed in value can be an int or it can be a string. If it is, for example, a float, we would get an error by Mypy. So at next, we have here optional and callable. This I will talk about in the next video, so I will skip this for the moment. Then we would have, let me see, let's go a bit further. We would have, for example, here for generic concrete collections, the dict type. And here we can define that, for example, every key of the dictionary should be a string, and we can define every value of the dictionary should be an integer. So here, this dict of string, int just says every key is a string and every value is an integer. If you, for example, have no really constraint on the value type, you could use dict of string, any, since then you say, okay, the value can be of any type, but the key must be a string. So that would be a use case where you can use any. Or if you want to say, okay, the values can be of type int or float, you can say dict of string, comma, and then for the value type, you can use a union, for example. So this abstract dict base class here can be used to express what the key types can be and what the values types can be. Furthermore, we have here an abstract list base class, and here we can say what types are allowed in the list. Yeah, as you know, a list can take different types in Python, so you can store in the same list an integer, a float, and a string, for example. But if you only want to allow that the list holds integer values, you can just say list of integer, for example. The same holds for the set, for the frozen set, and the same holds for the tuple, for example, as I showed before. So here are, as you can see, many abstract base classes that can be used for such kind of type annotation. The next important thing here is some collections from the abstract base classes module, so collections.abc. And here we have the abstract base class for an iterable. As I said before, if the parameter just has one constraint that it is iterable, you can use the iterable type annotation. If the parameter should be, for example, a generator, you can type annotate it by the typing.generator abstract base class, and so on. As you can see here, many abstract base classes defined. And for the most use cases, these are already defined in the typing module. If you have a really specific use case, you can define your own types. Okay, to finish the video, I will show some Python code here that I have prepared. Here I'm in the more to type annotations.py file, and here I have prepared a function that is called print container values. So we have here one parameter that is called container, and my constraint is here that this container, or that the argument that we pass into the function later on, should be at least an iterable container type. So for example, I could say it can be a list, a dictionary, a tuple, or abstract set. So if I have several types that are allowed, as I said, we can use an union. So here I created a type alias. So I said here allowed containers equals to this union, and now I can use this type alias later on. So I used here as a type annotation for our container parameter the type of allowed containers. And if I hover over this type here with my mouse, I can see the types that are allowed here, for example. Now I would see, okay, I iterate over the container and I want to print the values. And now you might think, okay, but if you iterate over this dictionary, you don't get the values, you get the keys. And that is correct. So now I would see, okay, I want to remove here the dict from the union, so the dict isn't allowed anymore. And if I scroll down a bit, I call here the function 3 times with a list, with a dictionary and a tuple. And now Mypy would say here in line 32, argument 1 to print container values has incompatible type. Because we have passed in here a dictionary of string keys and integer values, but the expected type is a union of list, tuple, or abstract set. So here we would pass in an argument that is not of any of the allowed types we listed in the union. And now Mypy would show us an error here, as we saw. So type annotations in combination with Mypy can be used to scan your code before you execute the code for potential issues. So next I have another function here that is called inner product that takes an type alias that is called vec of t, and here I have created a type var. A type var is something like a generic type where we define a name. So here I have the type var class. At first we define the name, and then we can define the types that the generic type can be. So here I said I have the type var called t, and the allowed types are int, float, or complex. And this type var can now be used, for example, here in line 16, where I said, okay, this vector is a type alias for an iterable of tuple, and this tuple should store exactly 2 values, and the 2 values should be of this type var type. So I have a tuple with 2 values that are an integer, float, or a complex number. If I scroll down now, I see here I get a warning by Mypy, namely argument 1 to inner product has incompatible type because we passed in here a nested list. So we have a list of integers, and Mypy expected we have an iterable of a tuple of 2 integers. I could now fix the issue here if I remove the inner list or replace the inner list by a tuple, as we said above that the inner part here should be a tuple of 2 values. So now the Mypy warning disappeared. If I would add here now a string, for example, Mypy should say, okay, you are doing something wrong because here the value of the type variable t of inner product cannot be object. Okay, the error message is a bit cryptic here, but at least Mypy says, okay, something is wrong with your passed in values for the value of type variable t. If I remove this string here and I just use a float, for example, and float is one of the allowed types here, as I said in line 15, the warning disappeared from Mypy. So as I said, type annotations in combination with tools like Mypy can be used to express the intention of the programmer. So if I'm the programmer of this function here, and while I programmed this function, I knew container must be either a list, tuple, or abstract set, for example. And if I haven't added the type annotation here, some users might, some programmers might use my function here, and they do not really know, okay, what types are really allowed here. Okay, for this simple function, it's pretty obvious it must be something iterable, but for bigger complex functions, it might not be very, very easy to see what types can be passed in here. So it's better to use a type annotation, because then everybody knows, okay, it must be, in this case here, a list, a tuple, or abstract set, and there are no questions left. Yeah. And in combination with Mypy, Mypy just checks your code before running it and find potential issues, as I showed here, for example. Yeah, since we do not allow a dictionary to pass in here, since if we would iterate over the dictionary, we would print out the keys and not the values, and then the function wouldn't do what the function is expected to do. Yeah. So we get here a Mypy warning, and now we as a programmer would see, okay, we have to fix this line. There's something wrong. Yeah. That is the main part, or the key part, of type annotations and Mypy. Okay, then we will see us in the next video. Bye bye.